Hi, so I want to do something a little different today. I was going to do a bunch of practice problems. I want to do a review of log properties. And do I like to do that rather than trying to figure out every property that we need to go over? I'm just going to do a bunch of random problems from, I have a quiz, I'll provide the link. The quiz is called Log 101 Quiz on my website. And so we'll just do some problems and see where it goes. So to start with, we have this one, log base 15. 625 over log base 15, 5. And then this one is clearly needs the change of base formula. Now let's look at what that is for real quick. The change of base formula tells us if we have log base A, B, then this can be written as log whatever. It can be any base, any valid base. Can be written as this. And so we also can take this and do this in reverse. So in this case, like our base is 15, but you notice the base doesn't matter in this case going backwards because the base is going to disappear when we go in this direction. So we can rewrite, in this case, so like this will be our B and this will be our A. And then so this whole thing can be rewritten as log base A, which is 625, but 625 can be rewritten as 5 to the 4th, but by this property of indices we can bring that to the front, and we have 4 log base 5. This piece is just 1, and so we're left with an answer of 4. My refrigerator's making noise. Okay, so that's correct. So we'll go to the next one, and the next one is too similar. Next one is log base 121 to 1331. That's interesting. Now, one thing to know, you might not recognize this, but 1331 is actually 11 cubed. 1331 is 11 cubed, and 121 is 11 squared. So let's rewrite this. We can rewrite the base as 11 squared, and then we can write this as 11 cubed. And then I'll do this quick, but we'll go over afterward, but you can actually go like this and like this and make a fraction and cancel those. And so if we have 3/2 log base 11, this piece is just 1, and so we're left with 3/2. Now I know that was probably too fast, so let's back up and see what happened for a second. The reason this works is because we could do it the slower way, would be to do change of base. So let's actually do it that way as a second way. And we'll see that the same thing will happen. So if we use, and we had the change of base in the last one, so I'm not gonna write it out again, but the change of base formula would allow us to write this as log base, whatever, it can be 10, 11 cubed over, we can write this as in the denominator log 10, 11 squared. Oh, that was silly. Instead of doing 10, let's do this. Let's make the base 11, because we can choose whatever we want. So let's choose 11. Let's choose 11. And then by indices, we can move the 3 here and the 2 here. And then we have our 3/2 log 11, log 11. These are just 1s, so we get the same answer, 3/2. Now actually I could have left it as log base 10 or whatever. Let's say I was crazy and I said we'll call it log base 17. Well, again, it doesn't matter because these are just going to cancel out. So I don't know, I'm just showing that there's a lot of different ways that you can get to the same thing, and it's kind of fun to play around with the log properties. So the next problem we have is log base 49, 27. Okay, this is actually the same property, but just a little more complicated. We can rewrite this as log with a base 7 squared and 27 is 3 cubed. And so again, we can bring this to the front as a fraction, and we're gonna have 3 over 2, just using these exponents, log base 7 of 3, and that's gonna be our answer. Next problem, we have log base 14, 196 equals y. We can do this a couple ways. The important thing to notice is that 14 squared is the same thing as 196, so we can rewrite this as log 14 to 14 squared equals y. But then using this little trick, we can bring the 2 to the front, and we have 2 log base 14 equals y, but this piece equals 1, and so we're left with just y equals 2. Okay, next, something a little different. We have log base 7. Oh, this is too easy. We'll just do this one really quick. Oh, this is a 7. I don't know, maybe I should cut this one out of the video later. What do you think? So this is 2 and this is 1. 2 and 1 is 3. Now alternately, it's not gonna make it easier, but when you have this property of adding logs, you can multiply them. So you could rewrite this as log 7 equals 49 times 7. Log 7 equals 343. 343 is 7 cubed. I'm making this way too hard. Equals 3. That's too much. Let's just move on to the next one. We have 225 log. We have 225 to the log base 15, 12. Okay, now this would be really easy if this number was 15, because now we would just have 12. It would be the same property we used earlier of basically just, yeah, if the base is the same, then we just know it's 12. But it's not quite as simple. What we can do though, 225 is 15 squared. So we're not too far off. We'll rewrite this expression as 15 squared. Just being careful with the exponents. But then by our exponent rules, we can actually multiply this out, and we can rewrite this as 15 2 log 15 12. But then this can be put, seems like we usually go the other way, but we can make this the exponent here, and we have 15 log 15 of 12 squared. 12 squared is 144. And so by the property we saw earlier, we essentially cancel that, and we get for our answer 144. Log base 2, so log of 8 base 2 plus log of 1 base 2. Again, pretty easy. This is 3, and this is just 0. To get 1 in a log, it's always 0. So adding 3 and 0, we get 3. Next we have log base 25, 81. And I think I will use the change of base formula here. Let's rewrite this. We'll rewrite this as log 81 over log 25. And then let's assume it is the same base, so whatever, this is a 10. then we'll rewrite 81 is actually 3 to the 4th, and 25 is 5 squared. So then we can bring these to the front. We have 4 over 2 log 10 of 3 log 10 of 5. So 4 over 2 is just 2. Then here we can use the change of base formula in reverse, and so which will give us log base 5, so log of 3 base 5. That's our answer. Next, this is a little different. We have log base b. They're not telling us the base. 1000 equals 3. Okay. Sorry, there's a flag flying around. Okay, so to start with, let's write 1000 as 10 cubed. So 1000 is just 10 cubed. And then, but then we can bring the 3 up front, and we end up with 3 log base b to the 10 equals 3. And then let's divide both sides by 3, and we'll get some nice cancellation. So just to be clear, we have log b 10 equals 1. But by the definition of the log, this just means that b to the 1 equals 10, so that just means b is 10. And of course you might just like recognize the answer right off the bat, but it's good sometimes to work through it, the steps. Okay, next problem, we have log base 9 x equals minus 2. Okay, I think again here, I think the best way is to just use the definition of the log, which is to say that this means 9 to the negative 2 equals x, just rewriting it. Now a negative exponent just means that we're putting, we can rewrite it in the denominator, so we can rewrite it as 1 over 9 squared. 9 squared is 81, so we end up with just 1 over 81. Here's something a little different, maybe kind of easy. Oh, I'm rewriting it wrong. We have 25 log base 25. Well, the reason it's so silly is because when you have log base a to the a, it has to equal 1, because a to the 1 equals a. So therefore, this piece is just 1. So we have 25 to the 1 equals 25. Sorry, that was maybe a little too easy, but it's kind of good to see the variety. Oh, I like, okay, this is a good one, I think. Yeah, maybe not that good a one. We have log base 1/3 x equals 1. So again, let's just use the rule of the definition of the logarithm, and that's just going to be 1/3 to this exponent 1 equals x. And so 1/3 of the 1 is just 1/3. I was thinking because we had that in the base, we might be a little more challenging, but not really. So again, okay, I think this might be a good one to finish on. So we have log base 8 4 plus log base 8 128. Now, with this note, let's just review. You do have this property, log a plus log b equals log of ab. So we could multiply 4 times 128, but I don't want to do that just because the numbers are kind of getting big, so maybe let's just do it a different way. Let's look at, so everything here is a power of 2. So 8 is the same thing as 2 cubed. 4 is 2 squared, and 128 is 2 to the 7th. So I'm thinking about this, let's kind of think it out. So like, let's look at log, what is log 8? Let's log 2 base 8. Well, looking at this means that the cube root of 8 equals 2. So if we raise 8 to the 1/3, we get 2. So that means here, if this is 1/3, we raise 8 to 1/3, we get 2. So then, likewise, if we want log of 4 base 8, it's going to be 2/3. The reason for that is, like, okay, if we, let's go over here and we square both sides. This is a 4 on the right. This distributing inside is 8 to the 2/3. Putting it back in log form, we have this. So let's just mark this as 2/3 here. Then similarly, we can do the same kind of thing here, where we said, okay, we had our 8 to the 1/3 equals 2. We know 128 is 2 to the 7th. Let's raise both sides to the 7th power. And so then we're saying 8 to the 7/3 equals 2 to the 7th, which is just 128. So that means putting it back into log form, we could say log 8, log 128 base 8 is going to be 7/3. So this piece here is 7/3. So then all we need to do is add those two pieces together here, and we're going to have 7/3 and 2/3 is 9/3, but that's just equal to 3. And we could have, if we did it the other way and we multiplied 4 times 128, that's 512, and that's 8 cubed, which is going to be 3. Let's do one more problem really similar to that. We have log base 4 32 plus log 4, so log 2 base 4. Now we know the square root of 4 is 2. So therefore, let's see, so the square root of 4 is 2. 4 to the 1/2 equals 2. So then rewriting this in log form, we could say that log 2 base 4, just rewriting this like that. So this piece here needs to be 1/2. Now we know, okay, so we know how to find log base 4 of 2. We need to find log base 4 32. 32 is just 2 to the 5th. So let's see, so if 4 to the 1/2 equals 2, we can get the 5th, take the 5th power on both sides here, and then we have a 32 here, and we're saying 32 is 4 to the 5/2 equals 32. So rewriting that in log form, we're gonna have log base 4 is log of 32 base 4 is gonna be 5/2. So then taking this and going back here, we can just, actually that's a little too messy, so let's like rewrite this thing. So we have log 4 32 plus log base 4 2. This piece is equal to 1/2. This piece is equal to 5/2. Adding together, we have 6/2 equals 3. That's it. So I'll provide a link to the quiz. Please click subscribe and like this video. Thank you.